Continuing on, and I'm sorry this is so long, but I'm being very careful with you in describing the changes of amplitude and period. So here we have a cosine, and it's a curve, but we have it described as y equals -4 cosine 6x. So we have both an amplitude and period change. So we're going to work on calculating what we need. We know that y equals a cosine bx, that we take the a absolute value for the amplitude. So we have a equals -4. So the absolute value of -4 is 4. Now you're asking, what does -4 imply to the graph? Well, that's a good question because it flips it. If the graph, the normal graph, was like this, then the negative would be like this. So we're going to flip it. Okay, that's one thing. So now we're going to talk about the period. The period is 2 pi divided by b. Well, that means I have 2 pi divided by 6, which means pi third is the period. So we're shrinking it. And for trig, it means it's going faster. It's going faster. In a shorter period of time, it is completing a cycle. All right, so our first step, of course, is to find the new radian measures that create the quadrantals. All right, so here we go. We know that our quadrantals are 0 radians, pi half, pi, 3 pi halves, and 2 pi. So we're going to set the argument equal to the quadrantals and solve for new values. All right, so let's do the first one. So in our function, we have our b is 6. Okay, so we have 6x equals 0. So I'm going to divide by 6, and I get x equals 0. That's our first one. Then the next one is 6x equals pi halves. So I'm going to use the multiply of 1/6. And that gives me x equals pi 12ths. Very small, right? So that's the next movement. So then I have 6x is equal to pi. I'm going to multiply by 1/6. So x is equal to pi over 6. Then I'm going to have 6x is equal to 3 pi halves. I'm going to multiply by 1/6. And I'm going to take a shortcut. X equals 2 pi fourths. And then I'm going to take the last one, which is 6x is equal to 2 pi. I'm going to divide that by 6. So x equals pi thirds. Notice that this starts at 0 and ends at pi thirds. All right, so I have all of my mu radian measures. So the second part is to construct a t-chart. And of course, I've been doing the math, and I know it's kind of hard for you, but it's important that you understand the functional aspect of all of this. So I have y equals, and it is a negative, right? Our function was -4 cosine of 6x. All right, ready? Look at the function. We are good. All right. So our first mu radian measure was 0. So y equals -4 cosine of 6 times 0. So that equals -4 times, the cosine of 0 is 1. So I get a -4. 0, -4. My next one was pi twelfths. So I have -4 cosine of pi twelfths times and 6. Sorry about that, I wrote it backwards and I apologize. So that's the same as -4 cosine of pi halves. And of course I get 0 because pi halves is 0 times -4 is 0. Then my next one is pi 6. And in pi 6 I have a -4 cosine of, and this is 6 times pi 6. So that gives me -4 cosine of pi, which is -4 times that -1, which is +4. All right, then I have pi fourths. So I'm going to have the -4 cosine of 6 times the pi fourths. Okay, well, when I reduce that, and I'm going to use this guy because I need you to see that I'm dividing by 2. So that gives me -4 cosine of 3 pi halves, which gives me a 0. So it's a -4 times a 0 is 0. And then finally, I'm at my last one, the pi thirds. In the pi thirds, I have the -4 cosine of 6 times pi thirds, which gives me -4 cosine of 2 pi, which gives me a -4 times that 1, which gives me a -4. All right, so let's see. Well, what am I going to do? Well, we're going to do pi twelfths, and we need pi thirds. So I'm going to make this guy pi twelfths. This is my 0 pi twelfths. Then that's a 12. Okay, 12. This is 2. This is 1. This is 2. So this would be pi 6, because I'd have 2 pi twelfths, pi 6. Then I would have 3 pi 6, which is pi fourths. Then I would have pi thirds, the end one, which is 4 pi 12s. Okay, so I have pi 12s. Then I would have 2 pi 12s equal to pi 6. And then I would have 3 pi 12s, which would equal 1/4 pi 4s. And then I would have 4 pi 12s, which equals pi 3rds as you reduce. So this is what I have. Sometimes I have to state it so you'll know. Okay, now remember it's 4. So this is 4, and this is -4. All right, so at 0, I have -4. At pi 12s, I have 0. Let me shorten that so we can see it. There we go. 0. At pi 6, I have a +4. At pi 4s, I have a 0, and at pi 3rds, I have a -4. And we can see that it is flipped. It is an amplitude of 4. It is a period of pi 3rds. All right. So we have done quite a bit of information. So what have we learned? We learned if y equals a sine, oh wait, let me write that better. A sine bx, then the absolute value of the a number is the amplitude, and then 2 pi divided by b is the new period. And the period means cycle. All right, and we learned it for y equals a cosine bx, because they're both a period of 2 pi. We learned how to graph. By setting the quadrantals equal to the argument, and I said the argument was that bx, and solve for x. And that's the needed radian measure to create the quadrantal. All right, what an exciting amount of information. I have not used the calculator yet. I believe it is more important in section 4.2 that you handle all that you've learned. First, the quadrantals. Second, amplitude and period change. And third, how to graph. Thank you so much for listening. And we're done with section 4.1.